Let's take a closer look at friction. The reason we have friction is it's due to interactions that are happening at the molecular level. So, the surface of this crate here is slightly jagged, and the surface of this ground here is slightly jagged. So when you're sliding this object across this surface, it takes some extra force to get it to move. The more jagged this is, and the more jagged this is, or the more sticky things, happen when this surface has molecules down here that form bonds, tiny little bonds with the molecules in the surface. And to overcome those molecular bonds, you have to push harder. Um, so both of those are just reasons why there is this force that's opposing the motion, and that's the force of friction. We're going to be able to calculate how big friction is. It only depends on two things, okay? So this is our symbol for the force of kinetic friction. It depends on two things. One of them is called the coefficient of kinetic friction. This is a Greek letter mu, so it's Greek letter mu sub k. Okay, so the mu sub k means coefficient of kinetic friction. This value here just gives you in general an idea of how sticky the surfaces are with respect to each other, or how jagged they are. It gives you an idea of how rough and how difficult it is to push something across that surface, and how much force it's going to take to overcome that friction. So for example, like sliding like ice on top of another ice block would have a very small coefficient of kinetic friction. But sliding like, a wood crate across like a grassy field would have a much larger coefficient of kinetic friction. The other thing that the friction force depends on is the normal force. And that's the normal force that the surface exerts on the box, in this case, the box. Um, it does not depend on how the surface area of this object. Okay, so whether this object is on, this bottom of its surface, or if we stood it up on its side, there would be different surface areas in those two cases. It doesn't matter because the normal force is the same in each case. So the force of friction acting on the object will be the same. Let's go through a quick example. So let's say you push on a 10-kilogram cart with a force of 50 newtons across a floor that has a coefficient of kinetic friction of 0.3. And we want to know what is the acceleration of the crate. So I'm going to set it up, this problem, the way that we set up all of our problems. I'm going to have a free body diagram. In it, I have the normal force pushing up. Gravity is pulling down. The force of gravity is always equal to mg. In this case, I drew my pushing force going to the right, although it's not specified, but that's just how I'm going to draw it. And then because the object is being pushed to the right, it's going to move to the right. The direction that opposes that motion is to the left, so static friction is going to be pushing to the left. Now, even though I know this object is going to accelerate in the x direction, right? You imagine you're pushing a crate on the floor, you're pushing it horizontally. If that crate suddenly lifted up off the floor and floated up into the sky, we would all freak out and run out of the room screaming, right? Meaning, the object is not going to accelerate in the y direction. So normally, if we know the object is not going to accelerate in the y direction, and it is going to accelerate in the x direction, and the question is asking me what is the acceleration, we might just try to focus on the x direction first. However, this problem involves friction, and we know that friction is going to depend on how big the normal force is. So I want to know what is the normal force. And as we move forward and you get lots of practice with these problems, you might be able to look at this particular problem and say, they're not on an incline. There's no other forces in the vertical direction besides the normal force of gravity. And we are not accelerating in the y direction. So you might get so used to things that you can say, because those three things are true, the normal force is equal to mg. And that happens very, very, very often, that the normal force is equal to mg. That's very normal for that to be true. Again, the only times it's not true is when there are other forces in the vertical direction, when you are accelerating in the vertical direction, or when you are on an incline. Okay? So in the future, you might look at this problem and say the normal force equals mg, and then you can just jump right into the x direction. But let's say we're not that comfortable yet. If we're not that comfortable yet, I'm going to look at the net force in the y direction because I need to know what that normal force is. My net force in the y direction is my normal force minus the force of gravity. And the force of gravity, I can just write it as mg. My net force in the y direction is always equal to my mass times my acceleration in the y direction, because that's Newton's second law. So I can set these two things equal to each other, and I have n minus mg equals mass times my acceleration in the y direction. And now I can plug in numbers, remembering that my acceleration in the y direction is 0. This whole thing here is 0. That's why we get this usual case that n equals mg. But here I've plugged in the numbers, and I find that my normal force is 98 newtons. Okay. Now that I know what my normal force is, let's look at what's happening in the x direction. My net force in the x direction, well, in the positive x direction I have the pushing force. In the negative x direction I have the force of kinetic friction. What is the force of kinetic friction? That's equal to mu sub k, our coefficient of kinetic friction, times my normal force. And so here I've plugged in the pushing force, my coefficient of kinetic friction, and my normal force, and I find that the net force in the x direction is 20.6 newtons. Well, the net force in the x direction is always equal to your mass times your acceleration in the x direction, and so I know that my normal force is my net force in the x direction is 20.6 newtons. My mass was 10 kilograms, so then I can solve for my acceleration in the x direction.